So there are some basic principles that we have to understand in order to proceed. And if you try to learn them all at once, you just want to throw it all away. Okay? Here's one basic principle. Here's the number 2. I can multiply the number 2 by 1, and it will remain a 2. I have not changed it. It's obvious why. Well, you just multiply it by 1. Anything multiplied by 1 just stays the same number. But there are many variations of 1. For instance, the fraction 5 over 5 is also 1. That's 1. And 2 is essentially over 1. If I were to multiply 2 by 5 over 5, which is essentially 1, I get 10 over 5. This is still 2, and it's obvious because 10 divided by 5 goes back to 2. But this is another version of 2 right here, the fraction, 10 over 5. And all I did was multiply 2 by 1, just a variation of 1, to get this fraction. We have to do this in math sometimes when I want my 2 not to be over 1, but to be over 5. I have to find the variation of 2 in order to work with it. This occurs mostly when we're adding fractions. Multiplying fractions is easy, as I've said. You simply multiply the top and multiply the bottom. That's your new fraction. And it's annoying that multiplying is easier than adding. But if I want to add these fractions, I cannot, because this is different than this. So now we're going to get on to our second notion. That was our first notion, that I can multiply anything by 1 and it stays the same. And there are variations of 1. Here's my second notion. The easiest thing they teach you in school for adding a fraction is to cross multiply. That occurs when I multiply this by this by this, and then the bottom by each other. So let's just quickly look at that. This by this is 6. This by this is 15. And this by this is also 15. Let me just change this 3 over here to a 4. And we'll just make this a 5. And I'll add them again. So this times this is 8. This times this is 15. And this times this is 20. Now, they are over the same denominator. When you're adding fractions, you just rewrite the fraction with the same denominator, and you add the top numbers. 8 plus 15 is 23. So that means is 2 over 5 plus 3 over 4 is the fraction 23 over 20. And if I can simplify it, I will. In this case, I cannot simplify it. But we can see that this would have been difficult to come up with without doing it. Cross multiplication is great until you're dealing with numbers that are so huge that cross multiplication not only needs a calculator, but can produce many errors. So now I have to multiply this by this and this. That's calculator time. It's tedious and it's annoying and it makes you want to quit. But there's another variation. For instance, if I want to add 2 over 9 plus 1 over 3, I can say, well, I can cross multiply. In this case, it's not too bad. It's pretty easy. But I can also say, wait a minute, 3 easily turns into a 9. All I have to do is multiply by 3. Then it becomes a 9. But I'm not allowed to do that to just the bottom. But as you remember, we're allowed to multiply this fraction by 1, and it won't change that part of the equation. And I'm just going to multiply it by a variation of 1 that I need. I need a 3 down here, so that means I have to multiply up top by 3 as well. This will not change the equation, and that's the important part, but it will change this bottom. 3 times 1 is 3. 3 times 3 is 9. And it makes sense that 3 over 9 is the same fraction as 1 over 3, because if I simplify this, it goes back to 1 over 3. But in this current moment, I need to replace that 1 over 3 with 3 over 9. Now I can see that the bottom denominator is indeed the same. And the top, I can simply add them. 5. So I can see that 2 over 9 plus 1 over 3 is 5 over 9. But I could not have easily seen it in this form. It wasn't until I converted it to this form that I can do it. And that's the second rule. Fractions can only be added when this number is the same. It doesn't have to be a number. It can be x and y. So that was the second rule. And the third rule was I can multiply something by 1 and it will not change what it is. So 3/9 is the same as a third. Now this applies not just to numbers, but to letters. Let's say I have 2 over x squared plus 3 over x. Well, I can see down here, I can make x squared simply by multiplying it by x. But I can't just multiply the bottom. I have to multiply by a version of 1, x over x. X divided by x is 1. Anything divided by itself is 1. So that means if I multiply the bottom, I get x squared. And if I multiply the top, I get 3x. So that means, interestingly enough, 3x over x squared is the same fraction as 3 over x. They're the same fraction. I've just multiplied it by a 1. But now that the denominators match, I can add them. It's the same as having it over x squared. And now I can add 2 plus 3x. Note at the top, that's as far as I can take the top, because this term is not the same as that term. I can't add the 3 and the 2, because this is 3 apples, and this is just 2 1s. This is 3 x's, and this is just 2 1s. I cannot add them. They're not the same item. So that's as far as I can take this fraction. But that is indeed what happens when I add 2 over x plus 2 over x squared plus 3 over x. This is the final answer, most simple answer possible. I also can't cancel out here because this here has, when they're married with a plus, you have to put them in a bracket. And again, brackets can only be canceled when the same bracket exists at the bottom. Okay? So that means that letters can be treated just like numbers. Letters can be treated just like numbers. So that's probably the fourth rule. We have to look at ways that letters are treated differently. That brings you to this example that your teacher gave you, trying to show you that we can treat the letters just like numbers. Well, in this case, this is a cross multiplication exercise because 4 has nothing in common with x. But I wanted to show you something. This is another way of cross multiplying. What is missing in 4 that's over here? Well, an x. If I multiply by 4 by x, I get 4x. But I can't just multiply the bottom. I have to multiply the top. That means if I multiply this by x over x, the top becomes x squared, and the bottom becomes 4x. What's missing in this one that's over here? Well, it's a 4. If I multiply the bottom by 4, I get 4x. But I'm not allowed to multiply this, just the top and the bottom. I have to multiply the top by 4 as well. 4 times 7 is 28. 4 times x here is 4x. Note that this was another way of cross multiplying. X times x, x squared. 4 times 7, 28. 4 times x, 4x. I should have just cross multiplied, but I'm showing you that the principle, multiplying by 1, is the same. We won't want to cross multiply when this fraction gets complicated. We will want to learn this method instead. Okay? Notice that I didn't have to multiply the right side at all because I did not change these fractions when I multiplied them by a version of 1. I simply found a version that had the denominator that I wanted. We can now add this left side. We can now make it all over the same denominator of 4x. What's interesting about adding is that denominator, you think, well, do I multiply them? No, it's just now that they're the same, we can just put them over the same bracket. But there's another step here. I don't want this as a fraction. I can get rid of this as a fraction. I can multiply this left side by 4x to get rid of that denominator. But in this case, I'm not multiplying it by a version of 1. I'm essentially multiplying it by its reciprocal. See? 4x over 1. But to do that, and the reason it's important to point out that this is a reciprocal is because if this was 3 over 4 here, we'd want to have this format, but it's not. So really I'm just multiplying by 4x. It's canceling out, but if I multiply any left side of an equation, I have to multiply on the right side. This is an important rule to remember. I'll get into this. It's clear that it cancels on the left. And on the right, it simply becomes 12x. We're still not done. This looks like a quadratic. You can't quite see it. X squared plus 28 is equal to 12x. But I can subtract. I can make it 0 on the left side. If I subtract 12x from the right side, rather, I have to do the same on the left side. It becomes 0 here. And over here, if I rearrange it, it becomes a quadratic. It's not a solvable or factorable quadratic, but it's a quadratic. And if you remember, a lot of these formulas are equal to y overall. But when is y 0? When it's on the x-axis. And that's the only time you can solve it, is when it's equal to 0. Because you're getting rid of y, essentially, in order to solve it. And as we discovered, this is not solvable. It's not factorable. So you have to identify the a. What's the coefficient in front of x squared? A is equal to 1. What's the coefficient in front of the x? B is equal to minus 12. What's the coefficient over here? Well, it's this thing that's all alone. C is equal to 28. And we have to use the quadratic equation, which is b squared. No, I think it's minus b. Let's look up the quadratic equation. Yeah, it's minus b plus or minus the b squared minus 4ac over 2a. Now this part you should always do first, because this will tell you if there's even a solution. Because if this comes out as negative, this part here, there's no solution. If it comes out as 0, there's only one solution. You can just forget about it and solve this part. And if it comes out as positive, there are 2 solutions. So always solve this part first. Also note this plus minus simply means we're going to do this equation twice. I can get rid of this, by the way, right now. That was just our solution from having the same answer. We're essentially trying to get to this format to solve it. So that means I'm going to do it once in this format, when this is positive, and once in this format, when this is negative. So I'm going to do it twice, but let's solve this portion first so that we can just slap it into both equations. B is minus 12, but when I square it, it becomes positive. It's 144. And minus 4 times 1 is just minus 4. And times 28 is 56, 112. So minus 112. Well, 144 minus 112 is going to be a positive number. It's going to be 32. So since it's a positive number, I know there's going to be 2 answers. Just going to make sure I got my math right there. 56, 112, minus 112, 144 is 32. Oh. That means I can replace this part of the equation with the number 32 here and the number 32 here. I just need to come up with the square root of 32, and we wouldn't, because sometimes your teacher wants the action, the thing accurate. Now this minus is applied separately to whatever minus is there. So it's like minus 1 multiplying whatever b is. b is minus 12. So this minus 1 makes the minus b value positive 12. So wherever I see minus b, I can simply replace it with positive 12. So I get 12 plus the square root of 32 and 12 minus the square root of 32. And finally, a here is just 1. So 2 times a is just going to be 2. So I can just replace it here like this. Your teacher, so it's important to first find the factors in order to factor it. Your teachers might want this. This is very accurate because if I take 12 plus the square root of 32, I get this long number, and then I divide it by 2. So one of my answers is this. This is the x-intercept. This, comma 0, will be one of the points on the graph. And then one of my answers is this, 12 minus the square root of 32 divided by 2. Oh, I got to go back and see if I divided by 2. This is the other answer, but notice it goes on forever. It goes on forever. Just going to go back and make sure I divided the first one by 2 plus the square root of 32. This, yeah, I did. No, I did it wrong. So let's clear it out. 12 plus the square root of 32 is equal, and then divided by 2. So I got that totally wrong. I don't know what I did there. So I get this up top. And I might even check that twice because it doesn't make sense at the bottom. That 12 minus, so always clear your calculator. That's one mistake I'm probably making. 12 minus the square root of 32 equals. I think I got the bottom wrong as well, yeah. That. So I got both of them wrong, which is embarrassing. Oops. There we go. So I'll just replace it with that. I'll assume this for now is right. I can always graph the original function and see where it came up. So apparently this is the right answer. I should probably triple check because it's clear I'm tired. Can't hurt where marks are concerned. So I'm convinced the top is right now. And it makes sense that this is a little bit further away. These are the two decimal numbers, but I can see that's not accurate. It just goes on forever. And that's not accurate. Sure, if I had to graph it, these are going to be useful. But if my teacher wants it and says, I want an accurate, precise answer, I would not be done yet. You might say, well, I can't divide it by 2 anymore. And you're right, except that you can break this up as 12 over 2 plus the square root of 32 over 2. And this one is 12 over 2 minus the square root of 32. And I'm only doing this in case your teacher goes further. And in university, they want you to go further. Well, just as we can find common denominators here, you're allowed to break up the fraction into their original additions. 12 divided by 2 is quite clearly 6 in both of them. That means this can be replaced as a 6. And this can be replaced as a 6. Now your teacher might say that's accurate enough. But note that sometimes you might say, well, can I divide 32 by 2? No, you can't. No, you can't. But 2 has a variation. 2 is the same as square root of 4. Square root of 4, just changing fraction by multiplying by 1. Square root of 4 is the same as 2. And that means 32, now that they're both in square root function, can be divided by 4. And I get 8. It's quite clear that this is the simplest form possible and will yield me the same answer that I had when I did the long form calculation. And if anything, is easier to calculate with the calculator. There's my 8.82. There's my 3.17. So I got the same answers. That's how I know I got it right. But this is clearly a lot simpler. than this. So you have to watch out. You have to say, well, 2 can divide into that. And technically, I think 4 can divide into that. So I can come up with this answer. Your teacher might look. So this is the first stage. I want you to learn and understand it. So what did we cover? 1, fractions cannot be added unless the denominator is the same. 2, you can change denominators by multiplying something by 1. 3, you could also cross multiply sometimes and achieve the same goal. 4, sometimes all you have to do is identify the number that's missing and just multiply one of the fractions to change it to match the other denominator. And this is of key importance in what's coming up. 5, once you add them, you can simplify even further. Okay. 6, if you multiply the left side of the equation by something, you must multiply the right side of the equation by the same thing. This is not true when you're changing the fractions by multiplying by 1, like 4/4, because you're only changing the fraction's denominator, not the fraction itself, as we saw when we discovered that 1/3 is the same as 3/9, which is the same as 27/81. These are all the same fraction, 1/3, just with different variations that have to find the denominator. So these are important skills that you learn by using simple fractions and simple techniques of cross multiplying. The next video is about how we do these complex fractions presented by your teacher.